Hello students, I hope you all are doing fantastic out there, isn't it? So today we are going to see the reactions of alkanes, okay? So let's begin. Alkanes. Alkanes are, we all know that alkanes are single bonded saturated hydrocarbons, isn't it? So let me write that. Alkanes are single bonded, there is always a single bond between two carbon atoms in alkanes, okay? Single bonded saturated hydrocarbons, okay? Single bonded means bond between two carbon atoms or three carbon atoms is always single bond, okay? Single bonded saturated hydrocarbons, and they have general molecular formula CnH2n plus 2. So this is the general molecular formula for alkane, okay? CnH2n plus 2, where n is the number of carbon atoms present in that compound, okay? And the value of n can be 1, 2, 3 and so on, okay? Now the first alkane when n equals to 1, okay? First alkane when the carbon atom present is 1. So we write C instead of n1, 2 1s are 2 plus 2 is 4, CH4. So the name of this compound is methane, and the molecular formula for this compound is CH4, and the structural formula is CH, okay? Since carbon is tetravalent element, so it has 4 valences, so 4 hydrogen atoms. When n equals to 2, C2H6, the name of this compound is ethane, okay? Ethane. And the structural formula for this compound is 2 carbon atoms, single bond between 2 carbon atoms, H6, okay? So we write H, 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 C2H, 1, 2, 3, 4, 5, 6, C2H6. When n equals to 2, 2 2 is 4 plus 2 is 6. When n equals to 3, C3H8, okay? And the name of this compound is propane, isn't it? C3H8, 1, 2, 3, 4, 5, 6, 7, 8, okay? N equals to 4, C4H10, isn't it? This is butane, C, 1, 2, 3, okay? 4, 5, 6, 7, 8, 9, 10. N equals to 5. This is pentane, C5H12, okay? This is pentane, C, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? So this is how we write the molecular formula of alkanes and the structural formula of alkanes, isn't it? So we know this. Now let us come to our main point, main topic, that is the reaction of alkanes, okay? And alkanes generally undergoes 2 type of reactions, okay? First is combustion reaction and the second is substitution reaction or halogenation, okay? Now let us discuss about the combustion reaction first. Number 1 is combustion reaction. Alkane burns in oxygen, okay? Oxygen is very essential for combustion, isn't it? Without oxygen, combustion is not at all possible. So alkane, if it wants to burn, oxygen is definitely needed, isn't it? Alkane burns in oxygen to produce, okay? This is produce. Let me write properly. Produce carbon dioxide, and water. Alkane burns in oxygen to produce carbon dioxide and water, okay? And also heat is liberated. Heat is liberated. During this type of reaction, heat is always liberated, okay? Liberated. So let me write the general reaction for alkane. Alkane burns in oxygen. Alkane reacts with oxygen, means burns with oxygen. Alkane burns in oxygen always, okay? Alkane burns in oxygen to produce carbon dioxide plus water. Are you getting me? Alkane burns in oxygen to produce carbon dioxide plus water. Any alkane, when burns in oxygen, produces carbon dioxide and water. And at the same time, heat is also liberated. Heat is liberated. So this is the general reaction for alkane, okay? Alkane burns in oxygen to produce carbon dioxide and water. So let us take some examples. Number one, suppose this is methane, okay? The first alkane, isn't it? Methane burns in oxygen to produce carbon dioxide plus water, plus heat is also liberated, isn't it? Heat energy is liberated. So let us balance this reaction. So 2O2, so 2H2O, 2 oxygen, 2 oxygen, 4 oxygen, 4 oxygen, hydrogen 4, hydrogen 4, carbon 1, carbon 1, balanced. So methane burns in oxygen to produce carbon dioxide and water, okay? Alkane, not only methane, every alkane burns in oxygen to produce carbon dioxide and water, okay? And number two, let us take another example. Let us take butane, okay? C4H10 burns in oxygen to produce carbon dioxide and water, plus heat is liberated, okay? Now let us balance this reaction. So 2, 8, 4 to the 8 carbon, 8 carbon, hydrogen 20, hydrogen 2, 10, 20, 10 hydrogen, okay? 10 to the 20, 10. Now oxygen, 8 to the 16, 10 plus 26, 2 13 the 26. Okay, this is balanced now. 8 carbon, 8 carbon, 20 hydrogen, 2 10 the 20 hydrogen, 13 to the 26 oxygen, 8 to the 16 plus 10 oxygen, that is 26 oxygen. Okay, everything is balanced now. So the main objective, what I wanted to tell you is not the balancing the reaction. What I wanted to tell you is that alkane always burns in oxygen to produce carbon dioxide and water, okay? So this is what the combustion reactions tells us. Now let us see the next type of reaction. Okay, and that is substitution reaction. Number 2. Substitution reaction, or you can call this as halogenation also. Halogenation. And do you know what is halogen? Halogens are the elements from group 17 in periodic table, isn't it? Fluorine, chlorine, bromine, iodine, and so on, okay? So these are halogens, isn't it? So halogens are always diatomic molecule, okay? So F2, Cl2, Br2, I2. Halogens are diatomic molecules, so F2, Cl2, Br2, I2, and so on. So substitution or halogenation reaction of alkane is hydrogen is replaced or substituted with the halogen, okay? So let us see the example of methane. Only one example. Let me take this example, CH4. Methane, okay? CH4. So hydrogen, 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 hydrogen. Now it reacts with chlorine, okay? Let us take the example of chlorine. Chlorine is a halogen. Cl2, isn't it? Cl2. This means 2 atoms of chlorine, isn't it? Cl. Okay. Alkane reacts with halogen and substitutes hydrogen, okay? In presence of UV ray UV light or diffuse sunlight. Please remember this, in presence of UV light or diffused sunlight. Halogenation reaction always occurs in presence of UV light or diffuse sunlight, and one atom of hydrogen is replaced with one atom of chlorine. Okay, so this hydrogen and this chlorine reacts. Okay, let me take this. This hydrogen and this chlorine reacts to produce hydrochloric acid, HCl. This hydrogen and this chlorine atom reacts to produce HCl plus. Okay, now this hydrogen is gone. Now this chlorine comes in this place. Okay, carbon, we have 1, 2, 3 hydrogens, 1, 2, 3 hydrogens, and one atom of hydrogen is replaced with chlorine. Okay, we write Cl. So similarly, this reaction will not stop here. Okay, now carbon, here we have hydrogen, here we have hydrogen, here we have hydrogen, and here we have chlorine, isn't it? Further, reacts with chlorine molecule ClCl, 2 chlorine atoms, in presence of UV light, okay, to produce. Now this hydrogen will be replaced with this H and this Cl. Now this C we write here. Okay, 2 hydrogen atoms, we write here 1 H and here 1 H. Here we have Cl, isn't it? Now this hydrogen is replaced by this chlorine. Okay, this H and this Cl reacts to produce HCl. This hydrogen and this chlorine reacts to produce HCl, and this chlorine atoms comes in this place. Okay, now we have 2 chlorine, so CH2 Cl2. Okay, CH2 Cl2. Similarly, this will be replaced, this will be replaced, step by step. Okay, now let us write this in shorter way. Okay, we don't have to write all this structural formula. Let us write in shorter way. So first, methane CH4 reacts with chlorine Cl2 in presence of diffuse sunlight or UV light. UV means ultraviolet light or diffuse sunlight. Diffused sunlight. Now one atom of hydrogen will be replaced by one atom of chlorine. Okay, so CH3 and Cl. One atom of hydrogen will be replaced by one atom of chlorine. So that one atom of hydrogen and one atom of chlorine will combine to form hydrochloric acid, and the name of this compound is methyl chloride. Okay, methyl chloride, CHLORID, methyl chloride. The name of this compound is methyl chloride, and this is hydrochloric acid, isn't it? So this CH3Cl, the reaction will not stop here. Okay, CH3Cl will further react with chlorine molecule. Okay, in presence of UV light or diffuse sunlight to produce again one atom of hydrogen will be replaced by one atom of chlorine. Okay, now CH2 hydrogen, we have 3 atoms, so one atom will be replaced, so CH2, and Cl was already there. Now another chlorine atoms comes, Cl2, plus that one atom of hydrogen and one atom of chlorine combines to form HCl. Okay, now this is called methylene chloride. Methylene chloride. Okay, methylene chloride. Now CH2Cl2 will further combine with chlorine molecule in presence of UV light, okay, or diffuse sunlight. Now this hydrogen, we have 2 atoms of hydrogen here, so one atom of hydrogen will be replaced by one atom of chlorine. So we we have CH2, isn't it? Now we will have only CH, and this we have Cl2, isn't it? So we'll have Cl3 plus one atom of chlorine from here and one atom of hydrogen from here combines to form HCl. So this is chloroform. Okay, CHCl3. Now this chloroform will further 3Cl2 react with Cl2 gas, okay, CHCl3, okay, sorry, CHCl3 plus Cl2, UV light, CHCl3 plus Cl2 UV light. Now this one atom of hydrogen is still remaining here, will be replaced or substituted, substitution reaction or halogenation reaction, isn't it? This hydrogen will be replaced by one chlorine atom. Now we will have CCl4. This hydrogen is gone. Now chlorine atom will be added, CCl4, okay, plus Cl. This chlorine plus one hydrogen combines to form HCl. So this is carbon tetrachloride. Carbon tetrachloride, okay. This is carbon tetrachloride, CCl4. Structural formula is CCl4, Cl, 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 okay, carbon tetrachloride, CCl4. So this is how alkane undergoes substitution reaction, okay. So hydrogen will be replaced by halogens in presence of UV light or diffuse sunlight. I hope you got this. So this was for today, reaction of alkanes, okay. Stay connected. I'll upload more of the videos like this in the next session, okay.